The new XRP we came out with launched about a month ago, and there were significant upgrades that we applied to the platform based on feedback that we have received on the beta version. The two main aspects of the XRP that got upgraded were the control board and the 3D printed plastics. The previous XRP, the beta version, the main control board, we knew that we wanted something based on the Raspberry Pi Pico form factor, that same microcontroller from Raspberry Pi, the RP2040. And we also wanted the radio on there. In fact, we are actually going to implement basically all the exact same circuitry as the Pico W. And we were like, well, why not just solder the Pico W onto the board so we don't have to do extra engineering work? Worked as a really good solution for us initially. Discovered it actually had some challenges for us. We had some manufacturing challenges with soldering such a big module onto a board. And also Raspberry Pi had, last year was August or something, came out with the RP2040, which is sort of their next version of the RP2040, with a lot of major improvements on there. And we were like, oh, we want to put that on the board. And Raspberry Pi had the Pico 2 with that same processor, but we wanted to also implement some other features. Pico is sort of meant to be low cost and easy to use, and doesn't max out all the features. We kind of wanted to max out all the features because why not? So we upgraded the amount of flash on the board. Instead of 2 megabytes, it's now 16 megabytes, so 8 times more flash. The RP2350 also supports something called PS RAM, with adding an external RAM chip. So that means we've gone from about 250 kilobytes of RAM to 8.5 megabytes. It is literally over 30 times more RAM on the board, which allows you to do computation of large data sets, like images, for example. And I will have some things I'll talk about later on that. That also enabled us to switch to the larger version of the microcontroller that has 18 more GPIO pins. So giving a lot more electrical expansion possibilities, because on the beta version, every single GPIO pin was used, and we kind of wanted more. We ended up using 10 of the additional GPIO pins for a couple extra features, like additional servo headers. Instead of 2 servo headers, there's now 4 servo headers, so you can expand more with your actuators. Also adding an RGB LED onto the board. In fact, if I turn this on, is that going to do blinky? No, it's not. Not programmed in the right code. But there's RGB LED on here that you can use for more dynamic feedback based on what your program is doing. And of those GPIO pins, 8 of them we have reserved exclusively for the user to do whatever the heck you'll want with. So if you want to, slap on some circuitry, or you have some add-on board that you want to stick into your XRP that is manufactured by us or a third party, you could totally do that and really dramatically improve the electrical expansion possibilities with the XRP. In fact, we now actually have a second Quick connector. Who knows SparkFun's Quick ecosystem? Raise your hands. Okay, so I2C, I'm sure you've all heard of it. I know on the Robo Rio, it is terrible. Promise that with the new control system coming out, that will be much improved. But I2C is a wonderful, ecosystem, or wonderful communication protocol for daisy-chaining lots of different devices onto a single bus, sort of like CAN. And SparkFun has this very wide, repository of different I2C enabled products under the brand called Quick, QWIIC. And we've got 2 Quick connectors on the board, so you can expand with 2 different I2C buses to connect pretty much whatever the heck you want with. And just other general improvements around, like we've now got a USB-C connector because USB-C is wonderful. Love your Raspberry Pi. We want USB-C. And so that's kind of like the biggest things around the control board. Huge improvements around there. I'll also briefly talk about some of the 3D printed plastics. The design has been really optimized for 3D printing. Credit to Jacob for doing that. He's basically redesigned the whole thing from scratch and Onshape. And it's now fully open source, so you can access it and do whatever the heck you want with it. But we incorporated a lot of feedback from actually one of our partners at Cornell University. The Cornell does systems engineering, and they have done some fantastic things with the XRP. If you haven't seen it yet, come to the XRP booth at the Innovation Fair. You can see all the really cool things they've done. We incorporated some of their features, like putting these little notches into the rails so you can get things perfectly aligned, make sure they don't slide around. And else. It doesn't break. Oh yeah, durability has been improved.
We're making the
Yeah. Yeah, and also this, you can see the orange bar here is actually, when you buy it from us, it's gray, but I'm sure you print it whatever heck color you want. New battery cover on here, so the battery door doesn't fall off and break. It's just a lot more durable all around. And
so those of you that have XRPs and you're like, well, I want some of the features of the new one, you can easily just 3D print your own chassis now and add that in with those features.
Yep, we tried to maintain backwards compatibility as best we could so that you can continue using your old stuff and upgrade just like a few components in the new stuff. And that was really a big priority for us to make sure that, like new control board, it slots into the old chassis, for example. So you don't need to, you can only upgrade whatever you need to. I think I've been talking a little bit too long.
It's okay. I would cut you off if I really needed to. So we're okay. But okay, so we're going to move on just a little bit. And some people might wonder, okay, how does the XRP really relate to FIRST teams? How does it relate to this whole mission of FIRST? And really, from a FIRST perspective, we see XRP as this whole idea of, like we've already heard, right? One robot per child. It also really, really is great for the classroom. And I have a special guest and a good friend of mine that's going to come up in a minute and really kind of talk to that. But it also truly builds those skills for a competition team. So we kind of have this scale of emerging impact to sustained impact. And what that really does is for those students, whether you're a classroom teacher or maybe you're that kid that can't get their hands on a robot, but we can put the robot in the hands of a kid, suddenly they reduce that barrier that when they look at an FRC robot or they look at a complex FTC robot that maybe somebody has built, they're not near as intimidated. Suddenly that light bulb comes on for them. So this is kind of our strategy of kind of really using it as this emerging impact, this low barrier to entry to build skills for those competition teams in the long run. So as we look at that, how are we doing that? So this is kind of a small little graphic I put together, but XRP really is kind of seen as this almost pipeline I see through all of our programs. And you might be, a student might be exposed to it over here very first and not ever be really exposed to First Tech Challenge or First Robotics Competition. They might be experiencing on their own. But what we hear time and time again is once they start competing a little bit, kids always want more, right? And so that's where you involve First Tech Challenge and First Robotics Competition. But what we find is it's actually this cyclical process where suddenly students, your First Tech Challenge teams are using it to teach younger students. And it becomes a continual cycle, which is why I kind of designed this emerging and sustained impact, because it is about growing teams, but it's also about growing members on teams and growing skills on teams. And so it's really this kind of interconnected weave. And we do that through several different options. And it's things like in the exploration level, you might have summer camps, demonstrations. But on that learning perspective, you'll have classroom use, independent learning, team development. So it's about developing the skills on your team. And then even going into avenues of like really innovative designs. Drew mentioned the Cornell students. They're doing these huge innovative technology designs, thinking outside the box, where they could be solving a problem that maybe isn't a FIRST robot, but maybe it's for a sponsor, which could lead to internships and apprenticeships and lots of different things. So that kind of goes back to this full thing. It's this tool of a little robot with endless possibilities. And then I have a great example of that. So when I first took on or started working with the XRP project, I have a very good friend who, you always know sometimes getting into FIRST is a big problem. And I said, you can do this. This is back when I was a coach. I signed her up on the FIRST dashboard and signed her up with the FIRST team. And now she has grown her program from one FIRST Tech Challenge team to 4 middle school teams, plus she doesn't run the 2 high school teams. So now there's 6 teams in an area that's like 300 kids in the high school. So that kind of gives you the population area. But I'm going to introduce a good friend of mine, and her name is Missy Woods, and she's at East Grand Middle School. She's going to talk to you a little bit about how she's used XRP in the classroom, but also within her teams.
Thank you. All right, so I became involved with this at a really early stage and helped with the Mountain Mayhem camp guide. And so in my school, we have clubs at the end of the day. And so we brought in kids who were interested in the program and my current FTC kids at that time. And they helped to mentor the younger kids on how this program worked. And it was an incredible process. These kids were able to go through the engineering design process and build things for these robots. They were able to learn how to program it. And then they were also able to just really encourage those younger kids to build that love of robotics. And so what we found is after that was done, my next season, we had so many students who were in that club then join our first tech challenge teams and have that basis before they started. So they were able to, have that experience with programming it and building things for it and just going through that whole process. Then I integrated this into my classroom this year. And so I had 250 students working with these XRPs throughout the year, from engineering design process to building things that can connect to the servo arm. We use Tinkercad at the middle school, so I teach middle school level kids, 6th, 7th, and 8th grade. And so we use Tinkercad with that, but you can get all those resources right out of Tinkercad. They have those there. And they were able to build things in Tinkercad that could then be attached to the robot. We did some drag and drop programming with them and also Python. And so I'm really excited to tell you, too, that my first tech teams this year right now in the club are creating an event that they're going to have XRPs at for this coming up in the next couple weeks. And 5th and 6th graders, they're inviting them to come in and learn more about the XRPs, use Orbit Odyssey. So they're going to be using Orbit Odyssey to teach some skills, get those kids hands-on with the robots. And I just think that this is a great way to engage your community, engage the younger children, and get them excited about robotics as they move forward into these teams then.
Thank you. So as she mentioned a little bit, last year we had Mountain Mayhem. Not many of you, I don't think anybody sent here they used Mountain Mayhem, right? So Mountain Mayhem was our summer camp last year. And it has kind of a mountain theme. They have mountain passes, and it really boils down to the fact that I came up with the idea after being stranded in Denver and couldn't make it over Berthoud Pass for many a days because I happened to live in Colorado in the mountains. So it kind of was the inspiration for the game of a real world problem. So we developed Mountain Mayhem last year. We released it this time. This year we have a space theme, so it is Orbit Odyssey. And I'm going to turn it over to kind of my cohort. These full summer camps are really pretty much a trifecta, meaning Missy and I started developing some of that classroom curriculum content last year, but the game design, everything else really does happen with this great individual who is also doing a phenomenal CAD and engineering for Experiential, and his name is Jacob Willies, and I'm going to turn it over to him.
Thank you, Laura. So by show of hands, how many of y'all are in first teams and you do outreach? Yeah. So how many do like summer camps, outreach with small robots over the summer? So I myself, I'm an engineer, and I was a first alum. I'm a first mentor, and for over 10 years now, I've been with teams and I've watched teams that use small robots to do great outreach in their community, getting young kids excited about STEM and robotics. And so what we noticed is all these teams, it's a lot of work to put these camps together, right? So when I joined Experiential and teamed up with Laura and Missy, what we wanted to do is create these resources for teams that wanted to hold these great opportunities for these students in their community, but didn't necessarily have the resources to put their own game together, to find the kit. We wanted it all in one, and we'll see those resources in just a second. But to do that, we created a free and open source game here, Orbit Odyssey, to solve this problem. So the field is largely designed to be, we wanted to make it as accessible to as many people as possible. So it's all open source, designed in Onshape. The field CAD's public right now on our website. We'll have QR code up shortly. Most of it is 3D printed, so you can print it on your printer at home. And the rest of it you can get from a bundle from Andy Mark, the pipes, the wiffle balls, even the gaffer's tape. A lot of people do have those materials lying around for an FTC. So if you need those, if you don't, you can also use pipes from your local hardware store. That was the original, but we're so glad to be partnered with AndyMark and have this bundle available.
So the camp guide actually has approximately 17 different lessons in it, and it's everything from learning about more than robots and gracious professionalism and really setting that context, as well as even you'll notice like the Orbit Odyssey challenge. One of those biggest things for a first student is when they come in is, do they know how to do a game strategy? Do they know how to read through a game manual? Do they know how to look at any of those elements? So oftentimes when you get that initial first student and they get this onslaught of information, I have to build a robot and I have to do a game strategy and I have to do this. It's one of those things where it ends up, it's very overwhelming for students, particularly at that middle school and even next level. So what we find in this particular, and I saw this with students this year, and it goes back to Missy students, meaning when you can have those kids where they suddenly understand, oh, wait a minute, I know what an autonomous period is. I know what a teleop period is. I know how to look at points within each one of those on a scale that is at a lower level that's not intimidating. They're much, much more able to go do that on the competition team. So I found that's actually one of the most valuable components of this particular camp guide or the camp experience, in addition to learning those basic programming skills and everything else. And as they mentioned a little bit ago, we have lots of different implementation options, everything from 5 hours to 14 hours to a full 35 hours a camp. That really boils down to how much iteration you want to teach. Do you want to teach Tinkercad with it, where students are actually designing mechanisms, or do you just want them to compete in the game with a basic robot? So you can really scale this however you'd like on a very, very broad perspective. In the camp guide, you'll see we have facilitator directions, which includes everything from how to do classroom management. So for students, if you have students that are doing an outreach event, they may not know classroom management skills. They're not me, who's been a teacher for quite a while, and I will never take the teacher out of me, regardless of how long I work in first, or a Missy who's been a classroom teacher. So getting kids so that they understand how to have those classroom management skills, as well as, I tip of my slide, as well as even how you do each individual activity. So we really broke it out on all those perspectives. Along with that, you also have student guides. So you have actual student worksheets. So if you're a person that wants to give something to the student in front to look at, to fill something out, to help keep them engaged, because if you're doing this with the younger level students, what happens is they're hard to keep engaged. They have very little attention span. So if you can have something for them to look at to really ground them, we have a whole series of the student worksheets that you can print out based upon the activity to customize it at each level. Did we get it? Well, there's some really cool graphics that go with this with sounds, but this is Orbit Odyssey, where robots clean up space rubble and deposit it in goals. And so robots start in an autonomous period, where the robots are completely controlled or are operated on their own. They migrate to the zones to score rubble in both the low zone, which is worth 1 point, and the high zone, which is worth 3 points. I don't remember what we said in here. Parking. Oh, parking is also available in autonomous, sorry. And it is worth 5 points. You then start the 2-minute driver-controlled period, where robots complete orbits for points. Each orbit is worth 5 points, but if you do an orbit with a satellite, it is worth an additional 3 points, so it's 8 points. As you go towards endgame and you score, you also get points for scoring the satellites in the pedestals, or returning them to Earth is what we called it. And you also get points for parking, which was worth 5 points. And there's also a cooperation bonus where if both satellites are returned to their pedestals or Earth, it's worth 10 points. There are rules to the game and a game manual, just like a first competition. And there also are penalties, so you can't pin robots, and you can't obtain more than one game piece, and the penalties really stack up. Jacob and I are pretty proud of that. That was a team effort. And then there's kind of a summary to Orbit Odyssey. Have fun. It's a good time. It really is designed after Overdrive. It's that racing competition so that you can do that small level of like getting robots to race really, really quickly. Or you can take it that more advanced and get have teams design something that actually builds up a pickup mechanism. So as you look at building this field bag, you're like, okay, where do I get all these parts, right? Most of the parts are 3D printed, and you can download those from printables. So Jacob has done the great job of, they're also all available on Onshape. So you could actually take any of them and even modify them if you wanted to. But so you have all the 3D printed elements, which are the corner pieces and the center pedestals and even the trophy and the side walls. Those are all available on printables for you to just download, hit print, right? It is a lot of printing, I will tell you. So if you only have one 3D printer, you better put in like a week to print everything. But it's not that much either. So if you have multiple 3D printers in a lab, it definitely is doable in a fairly short amount of time. We also have the polls. And the previous FTC game elements, if you don't have those, that's what these are. We went to Andy Mark and said, Andy Mark, do you have some more of these over? And they were like, yep, we do. They have a bunch left over. So we've repurposed them into a kit to use for this. And these are from Velocity Vortex. I was getting there. I was like, yes. But some of us have these sitting around our lab if we did FTC, don't we? So our goal was, how do we help you do this in the most cost-affordable way? Some of you probably have plenty of the polls sitting around. So like with Missy's polls, we just repurposed the polls and hit print. So it really is available out there for you to create these games in this way, but they are available with those resources. A couple of things. How many people know that the XRP is in the WPI lib for FRC? Okay, so you can actually pull and use the FRC programming tools, right, to teach programming. With that, we have these two great little intro to Java classes I did back in COVID, which was a few years ago now, that basically teach you those fundamentals of Java. So it's oftentimes, one of the reasons I developed these courses was this fact that kids will take an AP Java class and not know how to transfer that knowledge to a robot or understand that same basic infrastructure in the code that they're learning. So these courses were designed for that. There's two different levels. It goes everything from, creating a very, very basic code to understanding command-based programming within FRC and teaching the fundamentals of that. So that's one component. We also have coming soon. So one of the things, the education team, and Missy kind of referenced this a little bit. So she's actually been contracted with FIRST to develop several different Python courses or several different programming courses. That's a very basic level, middle school level blocks in Python course, as well as the Tinkercad course. I have another contractor that I've worked with that we're doing even more advanced stuff. So these particular lessons here on engineering design process, creating movement and advanced gears. You see some very interesting 3D printed parts there in the background. Those will be coming soon and released throughout this year. So FIRST is undergoing a lot of transitions in the next couple of years. One of those is we're getting a new learning management system. It's not launched yet. We're in the process. But within this next year, you're going to start to see things change a little bit. And at some point in time, most of you, or at least the adults in the room, will have access to this learning management system. And once we get that kind of up and running, these will be in a catalog library that you can go find and search. So it's more, we get once a year to kind of reach out to you guys. So I'm kind of saying, keep this in the back of your mind as coming soon. But all of these courses would be available once we launch the learning management system and get it up and running. And so the other thing we haven't really talked about a little bit is the flexibility of the design. We said it's very open source. And one of the coolest things I just got Drew to do that's happened probably from December to now is I said, and I said this probably once we first got the XRP, I said, Drew, can you put the HuskyLens on this? Once I got exposed to a HuskyLens, I said, is it compatible with the XRP? Because I kind of like the HuskyLens, especially for FTC and for teaching vision processing. So I'm going to let Drew talk a little bit about, of course, I don't know how much time we have. 5 minutes, 10 minutes. Okay. So you get like 3 minutes because Drew could go on forever. But no, between the two of us, we're a dangerous duo. We also volunteer a lot in Colorado. So, yeah, you want to talk about HuskyLens?
Yeah, I can talk a little about it. Who's actually familiar with HuskyLens for advance? So, HuskyLens, you can see on the front of my little XRP here, I have this module sticking up, and that's the HuskyLens. It is a fully integrated camera raised vision processing module that has a camera and a processor and a little display. Maybe I'll turn this on here. That has some pre-built algorithms to do various detection things. So, for example, right now I have it doing face detection. Whether or not you can see it from back there, it's currently pointing at my face and putting a little bounding box around it because it can detect where my face is. And it can do that. It can also, I have a demo that tries to turn towards the face, and so now it's trying to turn towards me. It can also has AI systems built in. So, for example, if I point it at Lori and I push this button, then it has now detected. I'm going to do it from this perspective. Oops. It can detect Lori and then train on Lori to detect her in the future again. And it will automatically pick her up, and my robot will start turning towards her, just as my quick little demo. And it's a really easy introduction to machine learning type applications. It doesn't require any programming. You just hit a button and say, I want you to train on this, and it will detect that. It also has other features that I'm not even covered on here. Object detection, I think it has like a YOLO-based classifier built in. Line tracking, color recognition, even April tag detection. It is opinions about the April tag detection, but anyway, it has it on there. And it doesn't give you the corners of the tag. It gives you the bounding box. What? Anyways, and it has an I2C interface. And actually, just earlier this week on Tuesday, we launched the HuskyLens on the SparkFun storefront with a cable that adapts to the Quick ecosystem. So you can just plug that cable straight into the XRP control board, and we created a MicroPython library so that you can get the data off of it really easily and just get whatever is detecting. And so it makes a really easy way to get into vision-based processing with the XRP.
So one of those other things coming soon, probably a little later than the others, will be probably an intro to AI course that focuses on this type of thing, which I think is super cool. For me, as that coach and instructor and getting kids into that. That's a very low barrier of entry, right? Compared to learning the FTC program or learning the FRC program and then think where the kids can go from there. But they had that basics of using one of those AI tools. Other curriculum resources. So if you don't know this, XRP also comes with an entire course created by WPI Lib. And I'm going to let Brad talk about that just for a few seconds.
Yeah, one of the things that we did when we did the XRP, we thought it was really important that students could immediately get going with it and learn about robotics engineering. And so I was in the robotics engineering department at WPI, so it was kind of important to me. So we developed a course which has all of these modules. So you can go through it. There's all these modules here. You can use the course can either be done using Python or using Walkly. So you can program the robot with either of those, and learn about each of those things. And the course is designed so that you learn a little bit, then you play with the robot, then you learn more and play with the robot. So it's not like you have to read a whole bunch of stuff and then you do some little exercise. It's just constant using the robot for everything that you do. And it's free and it's open source and it's on this website. So you can find all this stuff. Actually, if you want to find links to all of these resources, like the course and the experiential page and all that other stuff, the user guide and the API guide and everything for XRP, you can go to, I put it all in place. It's bradhouse.com. I'm Brad. So bradhouse.com/XRP. And there's a whole bunch of links there. And it's all the stuff just on one page where you just find everything really fast, including the curriculum and all that stuff for the XRP. So, and so just to understand, there's two ways of using this, right? This is native Python on the XRP. The other stuff that Laurie's also been talking about is loading the first module onto the XRP, so then you can work WPI Lab program. So they're a little bit different. With WPI Lab, you can also do Python, but it's the FRC WPI Lab APIs. Got any questions? Anything? No. There you go.
Questions as a whole? Anybody have any questions about Cam Guide, XRP technology, anything else?
So with the CAM guide, what sort of level of preparedness or technical ability is expected of the instructors facilitating that?
because you can use blocks programming, the hardest part is probably getting the 3D parts printed ahead of time. So it depends. If you have an FRC team, you can reach out to the FRC team and say, I need all these parts off printables. Can you give them to me? And maybe the FRC team is the level of the instructor really is, if you can teach blocks programming, you broke it down mostly in blocks programming with a little bit of Python for doing Bluetooth control. But it's pretty minimal. And you know, like with Missy, we had 7th and 8th graders doing this, even the students themselves doing a lot of it. We did some in the background, but that the level of programming is pretty low. So the technical ability, I think, is on a grand scheme of things, when we compare it to an MPC to an FRC robot, the skill of XRP is much, much lower. I saw and had another question. Yeah.
Just a question on number of XRP robots for the camp. There's talk of 1 robot per child, but do you just need 4 for your Odyssey playmat, or how does that work?
You can implement it in a lot of different ways. Ideally, if you're going to teach programming, you can do 1 robot for 2 students. We use 1 robot per child kind of as that, like the cost of a textbook, you know, and as more of a marketing / you know, that type of thing. But the reality is, like when Missy taught it in her classroom, she was doing 1 robot per 2 kids. So because you're going to have kids, okay, test this, and it's great for them to have that collaboration. If you're running just, okay, I want to do a basic outreach event like Missy's going to do, where her kids are going to do, those kids are going to go through and program the robot and have it all set up via Bluetooth. And then at that outreach event, she's only going to have 4 robots on the field. So that whole thing of like with the camp guide, it's set up to be very, very flexible. You take it and use it how you want. That's the benefit of it being a camp, right? There's no advancement to this. There will never probably be an advancement with XRP in a lot of different ways. But what it is it's that customizable tool that you can really take and say, the little robot with endless possibilities to develop skills.
Yeah, what is the age range expected for the camps?
Age range, well, it depends upon what level you're going to do it at, right? So she's going to do it with 5th and 6th graders. I would probably say if you have the robot set up already where they're just driving and you want to do some sort of small little camp like that, you know, you could do it as low as 5th, probably even 34th if you really had to. I would say it's a little bit of a challenge even for her 6th, 7th, and 8th graders when you get into the programming and the details. So I wouldn't go any lower than that. And then the upper level is really, you know, if you're going to really dive into details, it would be closer to that high school level. To run the camp as written, it's really kind of designed for middle school.
So the teleop portion of the driving, how is that accomplished? Is that keyboard on the computer or the
So currently in the directions, we have a program called Pestle Link that is a Bluetooth option. So it's done with like a cell phone or a tablet. There's a new program out that we might and I'll just update the cam guide as we get it tested. But we have a new program that it could be more with the computer, XYZ keyboard, and a joystick, which I think is a little more reliable than using a cell phone and Bluetooth. So there will be a couple of different options, but there's a couple of different options right now.